So when we're trying to find the slope of this red line here, of course we can't find the slope exactly because we do not know points exactly on this line. We don't know what the line is. So what we're going to do is we're going to use the original function to help us find the slope of this line. So I want to find the slope of the line at x equals 2. So I'm going to approximate it by finding the slope between x equals 2 and x equals 3. So that's shown by this green line here, where we have it crossing through the blue function at x equals 2, and again up here where x equals 3. So we need to figure out the points in order to find out the slope. So we already know that x equals 2. So we need to figure out what is the y value that goes with that x equals 2. So we need to figure out what is f at 2. So we're going to sub that into our function. Oops. We want to sub 2 into both of the x's. So 8, half of 8 is 4. 4 minus 4 gives us 0. So we have our first point here at 2, 0, which of course we could have seen on the graph here. Then we want to go again at x equals 3 and figure out what is the y value that goes with that one. So 0.5 times by 3 cubed minus 2 times by 3, just going to give us an answer of 7.5. So we have our other point up here at 3 and 7.5. So we are going to go and we are going to find our slope using those 2 points. So we want to go y2 minus y1 over x2 minus x1. So this gives us 7.5 over 1, which equals 7.5. The problem with this is you can see there's quite a big difference between our two lines, our green approximation and the red line that we want to find the slope of. So what we need to do, and what happens in the next 2 slides, is we need to find points that are even closer. So instead of using 2 and 3, what we can use is say 2 and 2.2. You can see when I use those 2 points, my slope gets even closer. So when we find for those ones, so for between 2 and 3 we were 7.5, between 2 and 2.2 we actually get a slope. So the slope between 2 and 2.2, we get a slope of 4.62. And you can see that that's a lot closer. But it's still not exact. So we can even go one step further and go 2 and 2.02. So you can see that one's even closer. And the slope of this line we get m equals 4.06. So you can see as we're moving our points closer and closer together, it seems that our slope is trying to approximate 4. So I can say that the slope of the line, the red line that we had here, looks like it's going to be 4 due to the approximations of the other lines that we did. Of course, there's going to be ways that we can find this out exactly, and that's what we're going to learn on the next slide.